Today's first topic we're going to look at are ocean currents. And the sea surface temperature actually influences the air temperature. So our surface currents and our wind patterns are very similar. We have that warmer water at the equator that moves towards the poles where it cools down, sinks, and moves back to the equator. Now around the equator you're going to have higher evaporation rates because your sea surface temperature is higher where the sunlight is more direct. So that creates the surface circulation. So it's about 10%, just the upper 400 meters roughly of the ocean, that creates these surface currents. 90% of the ocean is part of the deep water currents in the Great Ocean Conveyor Belt, which we'll take a look at. And the deep currents are affected by differences in density. Temperature and salinity both are factors that are going to affect the density of the water. So what we're looking at in this map are the surface currents. You can see those that originate around the equator are in red. Those are our warm currents. And those that originate closer to the poles are in blue. Those are our cold currents. Upwelling is created when trade winds blow the surface water away from the coast. So here you've got trade winds are near the equator, and you can see they're moving the water away. And so when that happens, the colder nutrient-rich water from the bottom is going to rise to the surface or upwell and take its place. And this is very important because it brings nutrients to the surface that the fishing industry really depends on to provide the nutrients their fish need in the fish nurseries. Now, El Nino, and something that happens in the Southern Pacific Ocean off of the coast of South America, actually affects these upwellings. It occurs every few years. You'll often see it abbreviated ENSO, which stands for El Nino Southern Oscillation. And what happens is those westerly winds, or those trade winds, weaken, and so they no longer push that warm water across the Pacific towards Southeast Asia, because usually during a normal year these warm waters are going to cause the monsoons that provide the rainwater for growing food. And when they get pushed off the coast, you also have the cold water from the deep that upwells that helps the fishing industry in South America. Well, during an El Nino, when those winds weaken, that water is no longer pushed over here, and your monsoons are going to hit out in the middle of the ocean, and the surface temperature next to South America is going to be warm, and you're not going to get the upwelling. So not only does that affect the fishing industry, but also it's going to affect climate areas in other parts of the world. So here's another example of what happens. You've got the surface winds that are blowing the ocean water westward, and as the warm waters are pushed forward, the cold water from the deep rises to take its place. Now, the weather patterns that occur, you can see all the areas in orange, the areas where the monsoons usually hit experience drought, but also not just in the Southern Pacific, but you see issues over here in Africa, over here in South America. You get extremely high rainfall in the southeast U.S., and then certain parts of the northeast and northwest United States have unusually warm periods. Because when you affect the ocean currents in one area of the ocean, that's going to affect the entire Earth because of the Great Ocean Conveyor Belt that we'll take a look at.